So what is a quadratic equation? Yep, highest exponent is 2. So you have an x squared in it. A lot of times you probably heard ax squared plus bx plus c equals 0. When we're solving our quadratic equation, there are different strategies that we can use. The first one is trying to factor. You guys spent a ton of time factoring last year, right? So we're going to do some problems with that today. Remember, you have to get it equal to 0 first. So our goal is to have something like x minus 1 times x plus 2 equal to 0. How would you solve it if it was equal to 0? I heard a lot of mumbling. I couldn't really tell what anyone said. Well, if you were multiplying it back out, you would distribute. But if you wanted to solve, you could then set each of these equal to 0. This is called the zero factor property. Because the only way you get 0 when you multiply is if one of those two numbers is 0. And it has to be a 0. If I said like it was equal to 1, does that mean one of these numbers has to equal 1? No, 0 is special. So it has to be a 0 over there in order to be able to factor and solve. So let's try a problem. If I told you to solve this equation, what would you do first? Everything on one side. If you're going to factor, you want your x squared to be positive. So I'm going to leave it where it is, and I'm going to move the other stuff over. So if I want to move that negative x, we would have to add the x to the other side. If I want to move my 12, I would have to subtract 12. Okay, so it becomes x squared plus x minus 12 equals what? 0, and that's what we want over here. Now, we can factor. Sorry, just had a thought that I need to add something to my to-do list. Okay, what multiplies? Remember, multiplies to the constant, multiplies to negative 12, adds to your middle term, adds to negative 1. Set up like this. It's two things that multiply to the constant. So if they multiply to be negative, we have to have a positive and a negative. And they have to add to the middle coefficient. So they have to add to a positive 1. That's why the 4 was my constant. Now, if I wanted to solve this, two things multiplied equals 0, that means one of those has to equal 0. So we get x could be negative 4 or positive 3. Can you check yourself on these? Absolutely. Plug them into the original and it will work. How many answers are you always going to get for a quadratic? 2. The highest power is 2, so we get 2 solutions when we solve that. All right. Let's try another one. It's already equal to 0. The first thing you should always check in factoring is do we have a greatest common factor? And this time we do. We only have 2 terms. They both have an x, so we could take that x out. What are we left with when we do that? Okay, set them equal to 0. So that means the plain x could equal 0, or x minus 9 could equal 0. Add your 9 over. We get 9 not too picky. You might remember writing them, did you do solution sets last year? So we can write them in solution sets, and we'll see that a lot. I'm not going to count it wrong if you just say x equals 0 and 9. Okay, that shows me you know what you're doing. But don't be surprised if I write things in solution sets sometimes too. If I gave you this problem. What would we do here? First we have to subtract our 12x over. And you typically want to write it in order with the square term, then your x to the first, then your constant. Okay, we check. Is there a greatest common factor? No. You definitely need to look for that before you slip and slide, because if you miss it, the slip and slide will give you the wrong answer at the end. So always check for a greatest common factor, and also for slip and slide to work right, this needs to be a positive number in front. So if it were a negative 4x squared, what would I do? Yeah, we could move it all to the other side. We could factor out a negative 1, a couple different options. So slip and slide, remember you slide the 4, or slip the 4 down to the 9. Then we need to know what two numbers multiplied positive 36 and add to negative 12. Okay. Are we done? Then we have to, we start out multiplying by 4, so we divide our 4. 6 over 4 reduces to 3 over 2, so you slide the 2 back in front. So you get 2x minus 3 times 2x minus 3. This is equal to 0. So to solve it, we're asking ourselves, when is 2x minus 3 equal to 0? If you can't look at it and tell, then solve the equation. You would have to add your 3. Divide by 2. And we get 3 halves. But you guys told me I have to get 2 solutions. It's the same one. We got the same thing twice. When you have a repeated answer like that, it's called a multiplicity. We'll talk about that a lot more throughout the semester. So multiplicity is just saying how many times did that answer work. So this one worked 2 times. So another way to write this, instead of saying 3 halves and writing it twice, we would say 3 halves multiplicity of 2. We put M for multiplicity. And all that means is 3 halves showed up as an answer twice. It is both of my answers. You guys want to try a couple? Subtract over the 3. Slip and slide. So then that's x plus 9, x minus 2. Divide by 6. You get 2x plus 3. 3x minus 1 equals 0. So then if we set those both to 0, and solve, we get negative 3 halves you guys all know how to check it. You just plug them back in and see if it works. This one is set up, it's already equal to 0. So ready for our easy method. What multiplies to -7 and adds to -6? Set those to 0. And we get +7. Do we need more problems like that? Okay. Let's do just a couple final problems for today. And then we'll pick up with this stuff tomorrow. Let's go to let's say x squared equals 5. That doesn't work for my traditional like 2 parentheses because I don't have all 3 terms. But my x is here by itself. Can you solve for x? How do you get rid of the square? If you add a square root, what do you have to add with it? A square root and a square cancel, and I get my 2 solutions, positive and negative, radical 5. Okay, we have 2 options. One option, if you have an x minus 2 squared, could you multiply that all out? You absolutely could. You can multiply it all out, set it equal to 0, and solve. Does anyone see a shorter method? Square root. Because the only x I have is right here. So we can get that by itself. Square root, we have to remember plus and minus. So x minus 2 equals plus or minus the square root of 16 is 4. Now, number one mistake I see is right here, people add over the 2 and say x is plus and minus 6. That's wrong. Why? This is essentially two separate problems. It's saying x minus 2 could equal positive 4, or x minus 2 could equal negative 4. So if I add my 2 over, x would be 6, but if I add it over here, we get negative 2. So you do need to kind of separate those so that you can get 2 like terms. We had to do 2 plus 4 and 2 minus 4. Is another way of thinking about it. Any questions on that? One final problem, and I'll stop for the day. What if I gave you x plus 5 squared equals negative 49? What would you do? Square root. You add a square root, you do a square root and a square cancel. What is the square root of negative 49? Now, when I try to move my 5 over, I'm subtracting it. Can I combine it with my I? No. How do I want you to write your answer? Standard form, a plus bi. So we would say negative 5 plus and minus 7i. You guys remember doing this? Going okay? Alright, tomorrow we will work some more. We're not done with this section. I'm going to go ahead and give you a few problems out of the book. And then tomorrow I'll probably just add to it once we finish the rest of the section. So I probably won't collect this until Tuesday. But